Question 13 was coming from conic section. Conic section as a topic is available in the playlist. If you want to see more of the conic, the parabola, hyperbola, and ellipse, tap on the playlist and then you scroll down, you will see conic section as a full topic. So from here, this one was specifically parabola. It says the point P that is on a parabola y squared equals to 4x. I think you see that's the shape of that curve. The chord OQ passes through the origin. The tangent at P, now our tangent at P, you see there, is parallel to the chord OQ. Now this is my chord OQ. You study the two are parallel. The tangents at P and Q meet at R. Determine the coordinates of Q and R in terms of A and T. This is a sketch I try to put so that it can make some sense. You see that the tangent at P is parallel to the chord OQ. Now, I start by getting the gradient of this tangent here. Because if I get the gradient of this tangent, it's the same as this because they are parallel. So, to get the gradient of this, remember, at this point, the gradient of the tangent and that of the curve are the same. So now, I start by differentiating now that curve. So my curve is, if I differentiate it, divide through by 2y, you get 2a over y. So you say at at P, so my dy dx, when is that our x is 80 squared, and our y is 2at, bearing 2a over the y, which is 2at. And you see that from there, my dy dx is 1 over t. So now I come for the equation of the tangent. Using y, so now my point is here, so the y value is the gradient, then the x coordinate. Multiply through by t here, get a square, 1 times this. If you take this side, our equation becomes, now this one is going to be plus 80 squared. So this is the equation now of the tangent. But now, I want now the equation of this chord. Now, if I'm to get the gradient of this chord, remember it's the same. So the equation of this chord, because to get the point P, to get the point Q, I need the intersection between this curve and this. So I need to first get the equation of this chord. So chord or Q. Remember, they are parallel, so its gradient is going to be 1 over t. Reason? Because they are parallel. Now from here, I have at the point at the origin. So now I'll say, so y minus 0 equals 1 over t into x minus 0. I'm using this because this line OQ passes through the origin. I don't know this coordinate, that's why I'm using this one. And from there, you can start our y becomes x over t. Now, intersection, points of intersection. Intersection with the curve y squared equaling to 4ax. Why am I looking for the points of intersection? Because you see that this line OQ intersects the curve y squared equaling 4x at this point Q, but we know the origin. We need to get now these coordinates. Now from there, from my y squared equaling 4ax, now this one is going to satisfy this if they are to intersect. When we square, we have x squared over t squared equaling to 4ax. Multiply that side, x squared equaling to 4ax t squared. Bring everything this side, you have x squared 4ax t squared equal to 0. So either if you factorize out x, you get x minus 4a t squared equal to 0. So from there, you can see either our x is 0, comma, or our other value of x, when you get this to 0, you have 4a t squared. Now, for every corresponding value of x, you get a corresponding value of y. So from here, my y will be 0, and then from here, if I put this, my y will be 4at. Now, meaning the origin, the point O is 0, 0, trivially, as you see there. Then the other point Q, because they are the 2 points of intersection from here, it means that it's going to be 4a t squared, comma 4at. So that is the coordinate of Q. But we also need R. But it's that the R is the point of intersection between this tangent and then this tangent. Now, what do I need? I need to first get the equation of this tangent at Q. Now, we need to first get the gradient at Q. So gradient at Q. Now, the gradient at Q is that the gradient function is here, right? It doesn't change. Now, the curve, meaning the gradient at this point, is going to, the gradient function is this. But I'm going to substitute in the y at Q. So now, from there, my dy, dx is going to be 2a over y. So at Q will be 2a now over. I put in the y at this point, which is 4at. From there, if we simplify, you see that this one will give us, so our dy dx will be equal to, this is going to be 1 over 2t. So the equation of tangent at Q is going now to be y minus y1 equal to m into x minus x1. So at Q, you see that now I have y minus the at Q, which is 4at equals to my gradient 1 over 2t into my x minus 4at squared. Multiply through by 2t. Here you have 2ty minus, here I'll get 8at squared equals x minus 4at squared. From here is that I have 2yt equaling to, when I take this side, I have x plus now 4at squared. Now this is the equation of the tangent. So meaning, if I want to, at R, these two are meeting at R, intersection of tangents. Intersection of tangents. So now I just need sort of this tangent and this tangent here. So I start with 2y plus 4a t squared. Then I have the other one, yt equals x plus 8t squared. Then I solve these two. If I solve this, I get yt equaling to, x will go, I'm subtracting. So this minus this, I'll get 3at squared. If we divide through by t, my y becomes 3at. Then after getting y, you come here and you get the value of x. So my x is going to be from here, it's going to be yt minus 8t squared. So my x is going to be, but my y is here, 3at times t minus 8t squared. So my x becomes 3at squared minus 8t squared. So my x becomes 2at squared. Therefore, our point R, the x value, 8t squared, then the y value, 3at. So that is the point R. So that's how we had to handle that question in simple terms. It was just a matter of being okay with your algebra. Otherwise, everything is okay. That's it. If you want a full topic for parabolas, please visit the playlist. You will see more. That's it. I wish you well.